Good morning, guys. Today we're going to be talking about direct variation. And direct variation is just another way of describing a relationship between x and y that is proportional. Okay? And in direct variation, one variable will always be a constant multiple of the other. And that's how we are going to get into the constant of proportionality. And this is situations that vary directly. That's a key word, varies directly, can always be represented with the equation y is equal to mx. Now, this is going to be a little confusing because on your reference chart, it says y is equal to kx, but Ms. Medell is changing it to y is equal to mx for a specific reason. We've already talked about slope, which is m. You should know that m by now means slope. We've talked about slope, and we've talked about how no matter what, the slope is not going to change. It is going to stay constant. Therefore, m is the constant of proportionality. Okay, or you can also define it as the ratio between y and x. Okay, y to x. So to solve for m, all you need to do is divide the y value by the x. Okay, so I know this doesn't make sense, so let's get into what it looks like. There are multiple ways that direct variation can be given to you. Sometimes they can give you a graph. And in order for a graph to be a direct variation, it has to fit two of these what's the word I'm looking for? Requirements. It needs these two requirements. So the first requirement is that it must be linear. Now, if you don't know what the word linear is, if you look at that base word line, you need to make sure that your graph makes a straight line. Okay, so make sure that your graph is linear. And not only must it be linear, but it must also go through 0, 0, or the origin. Okay, it has to go through 0, 0. Okay, those two requirements. If it fits those two requirements, it is a direct variation. So here I've given you an example of what that graph looks like. Notice that is a straight line. One requirement is satisfied, and it starts at 0, 0. Okay, so that is your second requirement. Now, if it is a table, actually, I'm going to move this up here. If it is a table, there has to be a constant ratio for the m. Okay, and remember, we find m is equal to y divided by x. Okay, y divided by x. So what does that mean? Okay, so here is my table. And all I'm doing is taking the y and dividing it by x. So 5 divided by 1 equals 5. 10 divided by 2 equals 5. 15 divided by 3 equals 5. And then 20 divided by 4 also equals 5. Because all of these numbers, 5, 5, 5, 5, are the same, that means that this table has a constant ratio. Therefore, it is a direct variation. Okay? Now, we have talked about the equation, and that means that this equation must be represented in the form y is equal to mx. Okay? So notice, it's just y is equal to mx. There's no plus, there's no minus, anything. It is just y is equal to mx. And that is because you're starting at 0, so you don't have a y-intercept. So having said that, with your verbal description, the description should include a constant rate of change without, without addition or subtraction. So I should have that constant rate of change or that slope or the constant of proportionality. I should have that, but I should not have addition or subtraction. Okay. And that is it for direct variation. If you guys have any questions, please let me know. I am more than happy to help. But if not, you guys have a great day. I'll see you later.